Good morning, ladies and gentlemen, and welcome to the next session of Virtual Course 2024, hosted by Faculty of Pharmacy, Universitas Indonesia. In this session, we'll be hearing a presentation about in vivo investigations of natural compounds in disease models by Dr. Xiaobu Tan from Ton Duc Tang University, Vietnam. The session will be moderated by Ms. Callista. To Ms. Callista, the floor is yours.
Hello, good morning. Welcome back to the sixth lecture and the second lecture of this day. Our second lecture is entitled In Vivo Investigations of Natural Compounds in Disease Models that will be presented by Dr. Gia Bu Trang from Faculty of Pharmacy, Ton Duc Tang University, Vietnam. Before we begin this lecture, please allow me to read Dr. Jia's CV. Dr. Gia Bu Trang is a lecturer in the Faculty of Pharmacy, Ton Duc Tang University in Vietnam. She gained her PhD in molecular medicine from Chonnam National University, South Korea in 2015. She was a postdoctoral fellow at Alabama and Augusta University, United States. She has published numerous research articles in various reputable international journals, and her main research interests include functional food, cell biology, pathological animal models, bioactive compounds, and their bioactivity. All right, without further ado, please welcome our honorable lecturer, Dr. Gia Bu Chang. So, Dr. Gia, the time and screen are yours.
Yes, thank you for the Miss Muliadis. It's for well presentation. Okay, can I share the screens? Okay.
You can share the screen, please.
Copy. Okay, now please. Okay, can you see my screen now?
Yes, I can see your screen.
Okay. Okay, so let's start this topic today. Hi everyone, my name is Chabu Chang. I'm lecturer from the Faculty of Pharmacy, Ton Duc Tang University. Today, I will my pleasure to present the in vivo investigation of natural product in disease model. So at first, I also free to introduce myself again. So I think you already know. So I received my PhD degree in the molecular medicine in Chonnam National in 2015. And later that, I met the lecturer and researcher in Faculty of Pharmacy. And I previously also working in the Institute of Biotech and Food Technology Industrial University in Ho Chi Minh City. And after that, I the postdoc fellow in the University of Alabama and the other is Augusta University. Okay, I'm also in charge in a section editor in the Plant Science Today journal and also the member of the Vietnamese Mycology Society, a member of American Association for Cancer Research. So it's my brief introduction about myself. So now we continue with our topic today. In this topic, in this presentation today, I will divide into the 5 parts. The first, I will introduce you about something about what is the term of in vivo and animal model. And second, I will introduce about the animal model, some common use in the biomedical research. And the third one is some recent advanced techniques. And the fourth one is comparison for some common use model. And the last one is the bioethics and 3R principle. So I think you already know about the in vitro experiment. Dr. Do Bích Hằng already saw in the last previous lecture. So today I will briefly introduce about the in vivo. In vivo is the Latin in the scientific term. That means within the living and in living thing. It refers to the observation that take place inside in a living organism, such as a plant and animal. For example, I carry out a clinical trial of the new growth or an animal experiment are also in vivo study. In the animal model, in definition from the National Human Genome Research Institute from USA, animal model is a non-human spike used in the biomedical research And because it can mimic some effect in the biology process or the disease found in human. So that's called animal model. The animal model is a central part for the several biomedical research fields. You can see in the figure, at first we need to do in vitro in the cell culture, and later we can do some research in the organoid or the primary cell, and later in the animal model, and last one is clinical. So the animal model is essential for and also intermediate step for the clinical trial. They can use for the cancer biology, therapeutic, neuroscience, pharmacology, toxicology, neurobiology of disease. And also they can use for the recovery and testing the nucleus vaccine and other biologicals such as the antibody hormone to validate the required for preclinical study in animal. In the figure, you can see they have some phylogenetics. These three, they clarify some animal common use in the human. For example, in the insect Drosophila or the trapperfish or the C. elegans. C. elegans is some worm. And also we can see in the frog, some mammal can be used in the mice, rabbits, rats, or the monkey, also except wildlife for the phylogenetic resemble of human. In the figure, this one is the ACE2 protein. You can see in this one, human and the primates, like monkey and the chimpanzee, they also share the similar with the ACE2 protein, very high similar, 99%. In the classification, they have some animal model, such as the induced disease, like the mouse and ovis is cow. And you can see some pharmacology induced are also spontaneous strain, genetic modified animal, negative model, and also healthy animal. So in induced disease, it means we can administering some drugs and other biology to infect the injury or subjecting them to make the stress. In the pathogenic chain, is where the normal course of the daylight ribosomes themselves to develop the specific disease. GMO or genetic modification animal, this means subtract the animal with the knock in or knock out the gene or protein. And the fourth one is a negative model. That not suscept to certain disease, but serve to evaluate susceptibility to a specific pathology. And the final one is a healthy animal. In the lecture, I will introduce you some animal we use for make some cancer. This one is the breast cancer. We use the DMPA. DMPA is the tumorigenic toxin. They can make the cancer in the breast. So we inject in the breast, and after that we measure by the scale, and we can develop the tumor volume. And after that we can use the HE, also called the hematocylin eosin. This means we can slide the tumor and you observe the trend of the color and the structure of the membranes. You can see in it's something like the very trend. This means they already have something. They make the structure is different with the normal breast cancer tumor. And the next one is the patient-derived xenograft model. In this model, we use some tumor tissue from the donor patient. After that, we collect and we dissect it, make to the cell, and we inject to the animal, like the mouse. And after that, we observe something. In the figure A, they observe about the tumor volume between the treatment and the normal. We use some caffeine and silver, and they combine with the caffeine and silver in the different dose. You can see when you use the caffeine and silver, this means they have the pink color and the circle with the blue. You can see they prolong the time to achieve the tumor volume over 0.4. And in the B, they also see the free survival. This means that when you see something like how animal they survival when you inject the treatment and the cancer, And when you treatment with the caffeine and silver, they prolong the time survival of the animal. And also we can check it with the kappa 3. Kappa 3 is mean the some apoptosis protein. So you can see when in the figure C, when we treatment with silver on silver and caffeine, that make the tumor, the more the dark brown. It means the some kappa 3 already upregulate. It means that apoptosis it occur in the tumor, in the breast tumor. And the next is the complex different adjuvant to induce the arthritis model. This one figure showed us how the people, they make the model for the arthritis model. This one is the RAS. At first, they will inject the complex for adjuvant. After that, they will check the some mediator for the information, such as the BG. BG is prostaglandin, and you can see the plan and the arthritis cause and the trend in the body weight, the body impairment. How about the white blood cell and erythrocyte grade? And also they checking some cytokine like interleukin 1 beta, nitric oxide, interleukin 6, and also to see the some liver hypertrophy and secondary reaction when we interact with the CFU. In this finger, the panel A and panel C, the panel A show the normals. When you see the normal, the space between the two chronocytes is well smooth, and also they have very technique. First, when we check in treatment with CFA, this means this makes the some information happen. So the space is round and you can see the space is narrow, and sometimes the cartilage is deformed. The next one we can do with the induce the hepatic damage with the carbon tetrachloride CCl4. When TTCl4, they will make the some AST, ALT, ALB. This enzyme is the liver enzyme. Usually they not really in the plasma. But when you have the hepatocyte damage, AST, ALT, and ALP, they will include this case. They use some extract to see whether we co-administration with extract with the CCl4, whether they can recover the AST, ALT, and ALB expression. And also they test the some nitric oxide, MDA, SOD, glutathione, and this one is some the antioxidant enzyme. And also they test some inflammatory like TNF alpha, interleukin 6, interleukin 1 beta. And they showed us when we treatment with extract on of the parameter IST, ILT, ALB, they will also decrease to the normal level. And the next one, they also check with the some FH standing. FH standing is we can see evaluate the histological during the normal and the CCl4 and CCl4 treatment with the curcumin. The second one in the muscle trirum. Muscle trirum is some technique. When it's standing, they can see the fibers of the liver. You can see this one has some the blue color in the tray. In the blue color, it means they make some fiber grip, and they make the liver either non-function. And you can see that's when we treatment with the curcumin, the liver is recover. So that's why the blue color, they will decrease. And another part is some event techniques to detecting the some tissue and animal model. This one is the ELISA. ELISA in the operation of the enzyme linking absorbent assay. In this case, we can use some antibody to detect some antigen in the cell. And after that, we use the secondary antibody to detect the first antibody. In the second antibody, they have have post-rapid peroxidase. It means they have the peroxidase conjugate with the antibody. And after that, they use substrate E. The name is the TMB. They will make this luminescent. And we can check the picture from luminescent to see whether the cell explore something. And the next is the histo-ELISA technique. This one, the technique for quantification and localization of the tissue component. In this one, we will use the spread and recutting into the slide with the 1 millimeter. And after that, we can use some technique to, the second one is the ELISA. This means we can use the histology cutting, and after that, we use the ELISA technique to quantify how much the expression of some protein. Okay, the next one is the immunofluorescence AF. In this one, we can collect the lymph nodes, and after that, we assemble in parallel. After that, we slide in the 300 micrometer, and after that, we sending the light tissue with the antibody, and after that, we can culture the light tissue and after absorb. In this case, you can see they have the green color and blue color. It means you can see whether the lymph node survival or not. And the next one is introduce RT-PCR combined with immunoprobe labeling for electromyography. In this one, they similar with the histological ELISA, but in this case, we use, because you know that sometimes we don't have the antibody to detect some protein. So that's what, in this case, we use the RT-PCR. At first, we use the institute RT-PCR. It means that we use conjugate the biotin with the uracil. And after that, we use the Pacific primer, reverse and forward primer to make the PCR. After that, when the PCR, if they have the blood protein or that's mRNA, they will make more the ubiquitin, they make they make more the biotin conjugate with uracil. So that make this one more the biotin. After that, we conjugate with the mouse antibiotic and antimalarial conjugate antibody. After that, we use some substrate to see whether they will make some signal. And we can see the signal to see how about the expression of protein and how about this one, they will localize in our tumor or our tissue. And the fourth one is comparison and reference of the common animal model. In this study, we will divide to the 5 kinds. One is Drosophila, is fruit fly, and second is the zebrafish, and the third one is the frog, and the fourth is the rabbit, and last one is rodent, like the mouse and grass. In the fruit fly, they're very low cost, and the rapid generation time. This means we can make the more experiment in the very low cost and the rapid time. And the channel is well defined with small channel. They can use for study the function of the gene and the genetic modification. In rabbit, they have a low cost and rapid the generation. And some the embryo, when we in the embryo period, they're transparent, so you can see what happened in the orange and how they can make the spinal spin. And also the easy genetic engineering, we can easy to make the genetic modification organism and used to study development of disease. In the frog, the egg is easy to manipulate. The egg can certify outside of the animal and can use for the study the embryonic development. In the rabbit, they also have a short life cycle. They're very easy to handle. And the physiologic is close to human, and they use to study all kind of disease. In the rodent, because the size of this one very small, you can easy to handle. So the rodent like rat and rabbit is a more animal model. They easy to accept. They come possibility to modify the genetics and very similar to human genome and used to study all kind of disease. That is the comparison at the front of the common animal model. In deeply, some also show the significant limitation of some animal. For example, in the grass, they're easy to breathing, handle, and less gray care, easy to interpret between the grass and mine. They are mostly increased, so do not have the genetic variation, but they're not suitable for the model for information study. In the tuna pigs, they also another protein. They mostly outbreaks, so but they're suitable to study about the collateral mechanism, ATMAS model, fetal pancreas development, and parturition, Alzheimer's disease. But the limitation is the pool of information potential for virus. This means this one for unsusceptible for the some viral infection. So they cannot use for the some research like the Ebola disease. Other more animal like the grouse, sheep, and cows, they have potential. For example, in the grouse, they have potential to do the orthopedic study. And the model for the female or male sex reservoir and the sheep, they're easy to handle, easy to assemble. Physiology and anatomy in nature are similar to human and good to surgical model for bone and wound healing, asthma model. But they're mostly in breast strength. It means the variation of the genetic is very low. They're not our breast strength. And also, if you divide this one for the some disease and model, we can divide last the ischemia and repulsion injury of the spinal cord. The animal model is significant in the animal model is guaranteed, but the challenge is need the reverse model are required, like the swig, rabbit, and mouse. In cartilage defect repair with the biomaterial, they are Morin, Ovin, Labyrinth, Caprin, Porcine, Canine, and the eco model, very easy. But the challenge is in regard to the cartilage technique, the drawn biomechanic, and also the ethical and the license matter, because we can, when you do with the big and something like a canine, we need to have the vegetarian license. You cannot use the like a student or something not untrained can use make the model. For example, another model is the animal model for study the land regeneration. Some model like the cockroach is the insect, zebrafish, mouse, rat, dog, and hound. That on this one have something like the broadcast. They similar resemble within the animal kingdom, trip and list the ethical variation. But the challenge is that not ideal for the less resemble with the human. In the mouse, they trip fast round where attached genome, many spy and transgenic trained mammalian. But the challenge, they found that this one is a truthful for the human trial. It means when we use the mouse like the model for the limb restoration, we cannot use this to directly translate to the human. Usually they use in the dog because it lot of size and higher physical activity cheaper than horse. But the problem is they need to more ethical constraint. It means when we do with the dog, we need to have approval from the bioethics committee, and they're more mature periods than the rotor. It means they make more time and expensive for the cost to hosting this one. And the next one is the bioethics. In the last one, the bioethics, they have some general principle. At first, the experiment must be indispensable. This means we need to thinking before we study this experiment, whether this experiment we can integrate or use another model, like not use animal model, for the specific purpose. The second rule is that the suffering of the tracks must be ethical justified. This means we need to show the reason why you need to make the plan and why you need to make this suffering with the animal, whether we can reduce the pain and suffering and the track with some like the blood or anything. And when possible, the 3R principle need to apply. And on an animal experiment, actual breeding and housing have to practical relation by control and authorized system. And another concept is the bioethics is the 3.1 is the Basel Declaration. The Basel in the 2010 is the call for more truthful and transparent and communication on animal research. And next is the 3R concept. It means replacement, reduction, and refinement. And last one is arrival right. Arrival right is mean the some aberration from the animal research reporting in vivo experiment. So this one in the fundamental principle of Basel Declaration. This one is respect and protect the animal entrust to us and not inflict the unnecessary pain, suffering, or harm to them, but adhere the high standard for experiment design and animal care. And the next one, we need to consider carefully whether the research involving animal address the question of importance and try to minimize the number of animals used for research and used for more suitable spies to achieve the attained rank of knowledge. Encourage the cooperation to avoid the repetition of the animal experiment. And we need to implement the highest standard for protection of the animal and public health. The balance between the interest of patient, society with our responsibility toward the animal when develop the genetic modification animal. Implement the high standard of education and training for all persons who work with animal and monitor their compliance with the standard. This means when we do some animal model and experiment, we need someone to training with you with the highest standard. And they will have the authorized body. They will monitor you whether we comply and we do everything on follow the group. And we also adequately regulate the important environment of statistics in the effort to promote the public understanding of science and promote the dialogue concern animal welfare in research by transparent and effective by communication to public, provide advice pay on the scientific knowledge and expert to political decision maker and government authorization on issue of research involve animal and their welfare. And the next one is the 3R concept. The 3R concept is mean the reduce, refine, and replacement. Reduce is mean we need to reduce the number of animals used in your experiment. Refine is mean we need to find maybe the humanized way and refine the tech to call the animal-led dress and pen. And replacement is mean we need to replace the animal study with other methods like the in silico stacking or in silico analysis. So replacement is mean refer the technique or effort that directly replace or avoid the use of animal. Replacements can broke down into the two categories, and full absolute and a partial. In the full absolute replacement, it means we avoid to use the animal completely. Some example like the training mannequin or the human tissue and cell computer model and physical logical system. In the partial replacement, we can still require the animal use, but the animal do not experience and pain or distract during the study. For example, we can use the animal deprive the tumor or tissue organ for in vitro study, therapy embryo. And for example, transcutaneous electric resistant test. This means we can start with something in the animal, and this one they can use the animal to other study. We just use something like where the testing the kin of the animal, they can resistant with the electricals or not. And the second concept is the reduction. Reduction involves that have obtained the comparable level of information from animal. Scientists can reduce the number of animals using the resource cost strategy, such as the appropriate experiment design. Excuse me, can you hear me? I'm sorry.
Yes.
Okay, thank you. Because they say that my internet is unstable. So the next one is correct the statistical evaluation and the sharing shot and animal. And the third one is the refinement. Refinement refers to the modification of the humanitarian and experiment procedure that minimize or eliminate the animal plan or detract and improve their welfare. The field sample for refinement or anesthetic or anesthetic. This means we need to check some the pain reliever or something make the animal sleep during the experiment. And we can handle animal with the humanly. It means we make it not stress and less painful. And also in the environment instrument and human endpoint, like we can use the skilling with some CO2 inhalation. It makes the animal die very quickly, and they cannot prolong the suffering, the pain. The next one is the Ivor guideline. Ivor guideline is mean the animal research and report in vivo experiment that are a checklist of recommendations to improve reporting for research involve the animal. They maximize the quality and the reliable of public research and ample order to better quantify and evaluate and reproduce the animal experiment. So one of important question when you do the arrival guideline is whether we use the sufficient sample size. To make the calculation of sample size, you can do the two methods. One method is the power analysis. You can do with the some online software like the G power software, or you just can use with the formula like correct the sample size equal with the sample size divide with 1 minus percent attribution divide to 100. Another method, we can use the law to minimize the return of result equation. That equation they writing by the E. E equal with the total number of animal subtract with the total number of the group. If they about the 20, it okay. If over 20, it means we saw much of the animal. We don't need to do that. We need to make it smaller. And when they reach the 20, enough to make your they make the something like ethical. The number of miles is sufficient to make the reproduce. And also we don't make the too much of mile when you make the painful. And I will show you this one arrival essential 10. They have many questions. And first question is about the study design. For each experiment, we need to briefly detail about the study design in group. How many groups we need to compare? The group being compared, whether include the control group or not. If no control group have been used, we need to give some explanation. Then second, how about experiment unit? For example, single animal, the little mass, or the case of the animal. The second important question is sample size. Whether you specify the exact number of the animal units occur for the group, and the total number of experiment also indicate in the total number of animal used. Explain how the animal sample size were designed, whether we need some formula or some the evidence or some the guideline. For example, in the some guideline in the Europe, when we do the sum in the Finland, when you do the sum experiment, if you below the 7 mile, they not ask you to give the formulation. If you have the 7 group and 7 mile, they will ask you how you calculation the sample size for each experiment. Then the third one, when you do experiment, sometimes we need to exclude the number of the animal. So they're asking about the exclusion and inclusion criteria. Describe any criteria used for include or excluding animal. For example, during experiment or data point, some might they will die. Or for example, in my case, when you do the cancer research, in the guideline in the US, if the tumor size in one dimension that over the 1 centimeter, we need to sacrifice the mind, don't make them to suffer the pain anymore. So that's why when the tumor size that over the 1 centimeter, I need to kill the mind. So it means we need to exclude the animal. And specific if the criteria were established appears. If no criteria was set, please say the some explanation. For each experiment group, reporting any animal experiment unit and data point not included in the analysis and explains why. If they know exclusion, also say in your proposal. For each analysis, report the exact value of n. It means that each animal in one group is similar with the sample size, but it means n is mean how many miles in one group you do. And the randomization, it means whether we do the some randomization during we make experiment, and describe the strategy due to minimize the potential of confounder. such as the order of treatment and measurement, or the animal care location and binding. Because when you randomization some requirement, you need to binding the sample and your animal. The people they treatment with the animal, they don't know whether the cross is the placebo or the real medicine, and also we don't know that the control or not. So we just writing number 1, 2, 3 and send to the veterinarian. The veterinarian they just know, they just write in the lab notes, this one is the treatment with the substance A, substance B, substance C, 1, 2, 3. They don't know exactly what substance we inject. Just the PI or the researcher who decoding, who coding, they know, oh, number 1 is the cross, number 2 is placebo, number 3 is the control, something like that. And number 6, outcome measure. We define the on outcome measure exact cell death, molecular marker, or behavior trend. This means what outcome you measure, we need to write it down. And for the hypothesis testing study, we specific the primary outcome measure. For example, the outcome measure that's used for determine the sample size. And in the 7, the statistical methods. We need to provide detail of the statistical method used for each analysis. For example, the software, or for example, ANOVA analysis, or the post-hoc like Tukey, Fisher, which model, which parallelism to use. Also deploy any method used to assess whether the data meet the assumption of the static approach, like the, how about you setting the B is lower than 0.5 or something like that. And what done if the assumption not meet? In the experiment animal, also provide the base approach detail. For example, the spine, the trend and subtrend, the sex, and also the age and development stage. For example, in the common rule, when you use with the mouse, usually we use the 6 to 8 weight with the 20 to 25 gram. It means it has something like the age and development stage for the mind. And also provide for further relevant information on proven of animal, health, immune status, genetic modification status, genetic time. If in your animal, we have something like the GMO, it means that some animal, they already trained the genetics. They need to show, you need to show them the result of the RT-PCR to show that this one already knocked in or knocked out that gene. On the appearance procedure for the experiment group include a control, describe the procedure that enough detail to allow others to replicate, include what's done. This means what procedure we use, how it were used, and when and how often. For example, we treatment with the one per day, one daily. This means 1 time per day, or 3 times per day, or maybe 5 times per week, something like that. And in the morning, in the evening, or and when include the detail of information, virus, and why. You can provide the explanation why we use this procedure and result. For experiment conduct, include the independent publication. We report the summary, the relative static of each sample. For example, the mean and SD, standard deviation, or if applicable, effect size with the confidence interval also need to improve. And the next one is the recommended set. In the recommended set, it means that just for the something when you're writing some paper, you need to report this one. The essential is what we need to do when we start the experiment with animal. But then in the recommended set, essential. First, when we do something for the public in the high reputation, we need to do something like the, for example, abstract. We need to provide accurate summary of the research, annual speed trend and set, key methods, principal finding, and study conclusion. Background, objective, ethical statement, housing, summary, animal care monitoring, and protocol regulation. We need to be careful when we do something for the animal study. We need to provide a statement indicate whether the protocol include the research question, key design feature analysis plan were prepared before the study, and this protocol order they already researched and approved by the bioethics committee. And I think that's all for my presentation. And this one is some reference I use in this presentation. So I hope you can check some help message like how we can do in the animal study later. So I think thank you for listening. So do you have any question? So I need to stop staring my kids. Oh, sorry.
Okay, thank you, Dr. Jia. That's a very detailed and insightful presentation.
Okay.
Unfortunately, because of our time,
The time. I'm sorry.
unfortunately, because of the time limitation, I have to end the discussion session. Maybe for those who have the question, maybe can directly email Dr. Jia or maybe Dr. Big from our previous lecture. Okay.
I think it's good.
Thank you very much for Dr. Jia for
Yes,
the
can you share
presentation.
me the certification? I'm sorry.
Belum.
Can you sharing me my certification? Yes.
Okay. Thank you, Ms. Kalista and our honorable speaker, Dr. Za Buchan, for the insightful session. Now, we would like to call upon Professor Padlina Chanisaputri to present a token of appreciation for our wonderful moderator and honorable speaker. To the documentation committee, the floor is yours.
Yeah. Okay. Okay. Okay, doctor. Thank you for delivering the presentation. It is very nice, very excited on the use of animal models in the investigation of natural product. Your in-depth knowledge and clear explanation about this one have provided valuable insight into this critical aspect of research, because we know the preclinical studies is very critical for to go to the clinical trial. We truly appreciate your time and effort in sharing your expertise with us. Once again, thank you.
Thank you so much. Thank the Indonesia University of Indonesia to give me the pleasure to giving my presentation, and also I will hope we can have the more cooperation in the next future. Thank you so much.
Yeah, thank you. Hopefully we still can keep in touch for the future.
Yes, thank you.
Yeah.
Once again, thank you, Ms. Kalista and the honorable speaker, Dr. Za Buchan, and for the amazing session. Ladies and gentlemen, as we move on to Lecture 7, I invite you all to the next Zoom meeting session, of which the link will be provided in the Zoom chat. See you all in Lecture 7, which will start very soon. Thank you.